This video will discuss what a microcanonical ensemble is and how it is like an ideal gas. The microcanonical ensemble is a system that is completely isolated from its surroundings. There is no transfer of energy or matter between the system and the surroundings, and the volume of the system remains fixed. In other words, this is a physical system where the total number of particles, the total volume, and the total energy are constant. The microcanonical ensemble is typically abbreviated NVE, with N meaning number of particles, V meaning total volume, and E meaning energy. The temperature of the microcanonical ensemble usually changes. In statistical mechanics, a microcanonical ensemble is used to represent the possible states of a system which have a specified total energy. An ideal gas is defined as one in which all collisions between atoms or molecules are perfectly elastic, and in which there are no intermolecular attractive forces. One can visualize it as a collection of perfectly hard spheres which collide but which otherwise do not interact with each other. In such a gas, all the internal energy is in the form of kinetic energy, and any change in internal energy is accompanied by a change in temperature. The curved line here represents the relationship between pressure, which is on the vertical axis, and volume on the horizontal axis for an ideal gas. And you can see the curve here. Now, in doing a microcanonical ensemble treatment of a gas with n number of particles and a certain volume, we get this graph. The different curves are called isotherms since they represent volume versus pressure at different temperatures. As you can see, the ideal gas graph from before, that curve is exactly like the microcanonical ensemble treatment of a gas. Therefore, you can see how these two relate.